Okay. Well, I think the time has started, so we're gonna get running here and start the presentation. Again, flag me if you have any issues, or you can't hear me, or the screen's not keeping up, or something like that. What we're covering, we're just going to do a general overview of the wet cells today, and we're also going to talk about AGMs. We're not going to focus on lithiums or nickel cadmium or anything along those lines. So, what is a battery? Very basic. I think everybody knows, it's primary source of power in this industry. Most of the systems that you're going to find in the floor care are either 24 or 36 volt. The batteries that we work with all have 2 volts per cell. So a 6 volt battery has 3 cells. A 12 volt battery has 6 cells. Some of our clients also work with golf carts or genies or other equipment, so we do work with some 48 and 60 volt systems as well, but predominantly we're going to focus on 24 and 36. Obviously everything that we deal with is centered right around rechargeable lead acid batteries. So one of the most common questions we start getting, people start looking at alkalines or lead acids, and then that leads right into starter versus deep cell batteries, which is what we're going to cover here. On your screen now, we kind of lay out that lead acid batteries have been around, and the concept has been around for many years, 155 years. It is a very basic principle, which can get complicated in the execution of it all, but basically you are starting off, your power source is sulfuric acid, and the oxidation reduction reaction with lead plates that are inside that battery. So as the system as the battery is utilized and it is discharged, that sulfuric acid the sulfur is bonding to the cell plates of the lead, and the liquid inside the electrolyte is slowly becoming closer to pure water. So you can see on a complete discharge, the lead and the sulfur are now bonded, and now you have pure water. Of course, it's the sulfuric acid in lead acid that makes it a hazmat issue. Obviously, you always have to treat lead acid batteries with care. You have two things going on there. One is it's full of an acid, which is dangerous if spilled or something along those lines. Two is obviously the lead is contained inside of it. It's perfectly safe as long as you keep it inside of the battery. Obviously, you never want to cut that open or do anything with the battery itself that could be dangerous. As the sulfuric acid is going through that discharge state and starts converting over to water, you do see the temperature at which the battery will freeze will actually increase. Now, most applications in the floor care market, you don't have to worry about freezing per se. Freezing is very bad for floor equipment for a number of reasons. Before you even have to worry about batteries, mostly about the water freezing in pumps and solutions and breaking lines and all the rest of it. Another caution to keep in mind is when you are charging lead acid batteries, it's releasing hydrogen and oxygen. Hydrogen is explosive, oxygen feeds an explosion. So you definitely don't want to be charging these systems around something that sparks, around welding systems, or in a smoking area or something along those lines. And as you utilize that battery, it is obviously going through water over time. So, and we're gonna talk about that quite a bit over time. So I won't take a lot of time here. One of the common questions we have is, hey, what's the difference between a starter and a deep cycle? Especially for people who are in retail applications, sometimes they like to grab a battery off the shelf and say, hey, my system ran great for 15 minutes, but it dies after that. What's going on? Well, starter batteries are made to deliver a high amount of current for a short period of time. It starts a car, and then after that the car's engine and alternator takes over as far as the power generation. So it has very thin plates inside of it, extremely thin plates, but lots of them. And that gives it the ability to provide a high current quickly. Deep cycle batteries, on the other hand, or marine batteries, because you could use it for trolling motors or for running, boats typically don't have their engines running the whole time, but they still want their electronics going. So they're called marine batteries as well, have thick, heavy plates. And these plates are designed to go into long-term use, so they'll be discharged and recharged, discharged and recharged. Well, when you discharge and recharge, you're also generating a lot of heat. You need more lead and sulfur contact period. So that's why that's designed like that. The thick plates are there to deal with that high usage and the heat that's generated by it as well. The typical wiring scheme in floor care is a series. So what that means is you're wiring the positive connection or the negative connection of one battery to the positive of the next, and then negative to positive, negative to positive. And it completes the batteries in a series. When you wire batteries in such a configuration, the amp hour rating is consistent across all. So a 225 amp hour battery is, and you wire 4 of them together, the output is 225 amps. But the voltage is multiplied by the number of batteries. So to get a 24 volt system, you put together 4 6-volt batteries. If you have a 36 volt, all you have to do is put 6 6-volt batteries together. That's why, as long as the battery compartment allows, that's usually the physical restraint. You can use 12 volts, you can use 2 12 volts or 3 12 volts or 4 6 volts or 6 6 volts. As long as the battery compartment supports it, then you can utilize it. The most common configuration we're going to see is 6 volt of the 225 amp hour, which falls into that golf cart battery class. We don't see this in the floor care, at least in the commercial side, with the parallel wiring. In this case, you could read the example, 212 volts, 115 amp hour, wired in parallel is still a 12 volt system, but now you have doubled the amp hours. On occasion, you will see the next one down, which is the parallel series combination. And this allows you to basically put 4 12 volt batteries together into that creates a 24 volt system. Any questions about that? And what I always say, going back to the wiring scheme, is if you're replacing batteries, make note of how it was wired and configured before you take them out. If you are wanting to make any changes to it, consult the service manuals to see what is supported, how you can configure that. In most cases, the battery compartments are sized very particular to how the system should be set up, and there's not really a lot of room to play around with changing different battery packs and, I'm going to go parallel series with this combination. There's only a few machines that actually allow you to switch back and forth. So either it comes out and made by the OEM to be a parallel series combination, I know Tomcat has a few of those, or it comes out to, in most cases, just to be the series. Basic fact of wet cells is that the plates always have to be submerged in the acid bath or in the water. A flooded wet cell will have vented caps. Each cell has its own cap, and think of it as its own little compartment inside of that battery casing. So a 6 volt has 3 cells, so it will have 3 caps. When you're looking at a battery real quick, all you have to do is count those caps to understand, I got 6 volts or I have 12 volts in there. It's very easy to do. AGM batteries, on the other hand, are what fall into the class which is called sealed. Now, they're not actually sealed. There is the ability to vent, especially in the case of emergency. You know, the hydrogen gas is still an output of the charging process. It's just usually kept with inside the battery and recombinated into the actual solution. Um, the absorbed glass mat AGM batteries have a matting material inside of between the plates, so there's really no free water in there. If you punctured it, you wouldn't even get anything flowing out because it's all absorbed into that glass mat material. Because it is sealed and because that acid solution is locked up in that glass material, it is not considered a hazmat type configuration for shipping purposes. This gets really important that if you ever have to ship a battery and you want to ship it, if you want to ship an AGM, you can ship it overnight, or you can ship it on UPS, or you can ship it on common carrier, and you don't have to declare it as hazmat. If you want to ship a typical flooded wet cell battery, it must go freight. It's not allowed on the airlines. It's not allowed with just common carrier with UPS or FedEx ground. You have to ship it freight. You have to declare it as hazmat, and there's certain labeling restrictions that need to be put into place for that. The third type that we do see in the industry, on and off, it's not very common, is gel. Gel's been around for quite a while. Instead of having basically they've taken that electrolyte solution and have mixed it with something that makes it more like a paste, a gel. Imagine that. It is also sealed. There is no maintenance required for it. Tends to be a little bit more expensive than AGM nowadays. It's really, I see the gels more in the smaller propane style batteries. I think they've gone that way so that you can ship those on UPS and not have to deal with the restrictions, because even a small wet cell wouldn't be allowed to be shipped on UPS. So, but we don't see it that common in the floor care. What's the difference between gel and AGM? I don't see a lot of practical differences. There are some differences in charging, and when we get to that section of the presentation, we'll talk about that a little bit more. Okay. This slide's kind of a reader, and you know, I'm going to make the PowerPoint available to anybody who wants it. All they have to do is send me their email, type it into the question or chat, and say, hey, I'd like a copy of the PowerPoint. I'll send it to you. As I'm stalling, you can kind of read it. This is kind of like AGM versus wet, but it's really kind of written as all the advantages of AGM over wet. There's a few bullet points that probably should be added. On the wet side of it, wet technology is just proven technology. It's very consistent. From what I've seen, we deal with a number of different battery manufacturers. For the most part, the batteries all react the same. There's no little quirks regarding it. It's the charging technology that works with it is pretty down and dirty. It's not that difficult to work with. AGMs, being a sealed battery, the mixture of the chemicals, the mixture of the minerals, the amount of metals that they put into it, everybody has their own secret sauce when it comes to AGMs. Everybody claims theirs is a little bit better than the other guys. Charging technology is definitely a lot touchier when it comes to AGMs, and of course AGMs are about twice the price of wet cells. We have a slide in here on lithium ions. I won't take any time here just because we don't see that in this industry. And from a price point, you're looking at 4 to 8 times the price. There are certain restrictions too. You know, AGM's been driven down in price over the years. They used to be about 4 times the price. Now they're only twice the price, maybe even a little bit less than twice the price when compared to a flooded wet cell. But the principle of the two batteries are basically the same. It's a lead-based sulfuric acid oxidation redox chemical formula. Lithium is a totally different metal that they're utilizing. Different technology, different manufacturing, different reaction to charges and discharges. It's completely different. So I don't expect to see that into the floor care market unless something significantly changes over the years. Metal nickel, it's put in there. Hydride, common hybrid vehicles, not common in the floor care industry. How to remove and replace batteries. I think before it gets in, step one says disconnect batteries from the machine. That's an extremely important step. But let me go and say the first step really should be is to make sure the machine is turned off and the charger is not engaged or turned on. Now, if it's an onboard charger, just make sure it's turned off. If it's an offboard charger, unplug the charger, disconnect it from the machine. Then you go to disconnect the batteries from the machine itself. Most of the time there's either a 50 amp, 125 or 150 amp Anderson connectors. Red Anderson connectors are the standard for 24 volt systems. Gray Anderson connectors are standard for 36 volt systems. So if you see a red one, it's a 24 volt in the United States. A gray is 36 volts in the United States. Next is you remove the nuts and the washers and the jumper cables. This is, before you do all that, again, make sure you kind of make note of how the batteries are configured. Typical series combination, positive or negative to positive, easy to do, easy to accomplish. When you're removing the battery cables, I'll tell you right now, if you're going to replace the batteries, you might as well just throw the cables away. The cables are probably about 10% of the overall cost of a new battery replacement. And if you don't replace the cables, you're not going to see the performance. Just because, especially on typical flooded batteries, those cables will be corroded or will have corrosion inside of them. And where you have corrosion, you have heat generation. Where you have heat, you have loss of voltage, you have potential for fires, you have other issues. So take those $30 worth of cables, throw them away, and replace them. It's well worth it. Use a battery strap. Just be careful. Know what the batteries are before you start trying to take them out. Typical golf cart battery is probably going to be around 50 pounds. You can put the battery strap on there and pull that out. An L16, which is a 400 amp hour approximately battery, or 6 volt, or the big 12 volt 195s, which are about 115 pounds. You know, those guys are real heavy, and it's best to be using a two-man team in order to get those batteries out, especially considering you're getting them out of the battery compartment, which may require you to lift these 100-pound batteries 36 inches or higher. Basically, the same way you got it out is the same way you get the batteries back in. Install battery cables, your new battery cables, and tighten and fasten the nuts to complete the installation. I need to stress here, besides replacing the cables, make sure that you are getting those new, you are getting the nuts fastened down very tightly. You don't want to do it so tight that you damage the post, but you do want it extremely tight, extremely firm. If you do not have a nice firm connection on that, and that allows that battery cable to jiggle, you're going to get sparking. Where you have sparking, you will have heat, and that heat will cause that battery terminal to potentially melt the plastic around it and then destroy that battery. Of course, where you have heat, you have the potential for fire, so be careful with that. General rules, I'll let you guys read through this. A lot of this stuff's common sense. Again, you're dealing with sulfuric acid or where sulfuric acid has spilled in the outside. There's some residue still there. So make sure you're wearing gloves. Eye gear is always, important as well. Obviously, don't be smoking while you're doing this. And I think the most basic rookie mistake that it seems to happen when you're changing batteries is you take that ratchet, you take the bolt off, you lay the ratchet down, and you accidentally hit the positive post of one battery and the negative post of the other, or positive, and you get sparking. I could tell you from experience that's a rookie move, and you typically do it once but once is enough just to kind of wake you up and say, oh, don't do that again. And of course, you potentially can be damaged to the batteries with that. But the same thing goes with screwdrivers or whatnot. That's why a lot of times when you're doing maintenance inside of the machine or something like that, they suggest that you take the pads and you lay it over the top of the battery terminals. This way you don't accidentally put tools down on top of it. Okay, if you do happen to get battery acid on you, even if you suspect that you have battery acid on you, best thing to do is to go and wash that off. Now they say let it run under water for 15 minutes. If you suspect you have battery acid on you, wash it off as well, because sometimes there's that delayed 5 to 10 minute reaction before you actually feel the burning. So you don't want to mess around with that. If there's battery acid on the outside of the batteries and you're going to be just doing some maintenance, cleaning it up and whatnot, some baking soda. Baking soda has a pH of about 9 and will counteract. When you put the baking soda on top of the sulfuric acid, you may see some bubbling, especially if it's wet occurring. That's carbon dioxide, which is harmless, being released from that chemical reaction. So make sure that's baking soda, by the way. Baking powder is not as effective. Okay. How long should my batteries run? This is probably, the most frustrating thing for end users, is to answer how long this should be. So we've put together some. These are not theoretical charts. These are based off runtime. So your typical auto scrubber is going to have about a 50 amp draw when using red pads. Things that impact draw for when you're scrubbing is, pad pressure is one. If you have the pad pressure turned way up because you're doing some stripping job or something like that, you can see that it increases by 50% the amount of amp draws, which significantly reduces your runtime. If maybe you're just if you're just running the vac motor just to pick up some spilled water or something along those lines, you can see that it's half the amount of amps needed to run that system. So on the left side, it'll show the number of the volts for the batteries, and then the second column from the left will show you the amp hours. So the second one down, the 6 volt 225 amp hour, again, that's your typical configuration with the golf cart battery. So for a typical machine, you're going to get 3.14 hours of use out of that. So just over 3 hours on brand new batteries. Doesn't matter again, because it doesn't matter if it's a 24 or 36 volt, because that amp hours is consistent across. A little quirk about battery technology is that the chemistry, there's actually a setting in process with batteries when you first get them. So you actually won't see your best runtime until you complete 50 to 60 cycles, and that will actually be your peak of your runtime at that point. So if you put the batteries in when you first start using them, you're not going to see a significant difference. It should be pretty close to that 3-hour runtime, but you'll actually see that peak in that first 2 to 3 months, and then from there on, it's a gradual decline. Okay, one of the most popular questions we get coming into it, coming in as far as diagnosing batteries, is I have decreased runtime. Is it my batteries that need to be replaced, or is there something else going on? Our first question, we'll usually ask 2 questions. One is, okay, what is your decreased runtime? What are you talking about? Is the system running for 15 minutes, 30 minutes, or 90 minutes? That's really important. And has that decrease occurred rapidly, or has this been decreasing over a period of time? So if your batteries are over 6 months old and you've noticed that the runtime has just been dwindling down, that's indication that your batteries need to be replaced. If your batteries are under 6 months old, or they were giving you 2.5 hours of runtime last week and this week you're only getting 1.5 hours, well, that usually indicates something else is going on. Either can be a component inside of the machine that's heating up and failing, or your charger's not working correctly, or your charger's not working at all. And what I always tell people, when you go to diagnose a charger, the first thing you need to check is the circuit, the wall plug that the charger's plugged into. Especially in retail operations, the back of a grocery store or something along those lines, if that circuit's blown, there's a lot of times you can't see where you have to position the charger. You can't even see if the charger's turning on or not, but you see it plugged in the wall and you just assume that, like always, it's working. Check that plug. Make sure the circuit is active and you're getting juice out of there before you start going through a lot of high-tech trying to diagnose it. And then when it comes to, like, especially with Lester chargers, which are built very soundly, check the fuse. Some of these simple things that are low-dollar repairs. Now we're going to get back a little bit into battery testing. It's important to understand that on a 6-volt battery, that a healthy 6-volt battery should be reading about 6.3 volts. When you disconnect, if you fully charge a battery pack and you disconnect it and you put the leads on there to check say you check one battery, you're going to get more than 6.3 volts when it comes off the charger. You have a lot of what they call it's a superficial surface charge that's going to be there. As soon as you start putting a load on it, that surface charge dissipates, and the battery will drop back down to that 6.3 volts and run from there. If you have the charger on there and it's been charging the whole time and you aren't getting up to the 6.3, maybe it's only getting to 6.1, then you need to test it further by either doing well, we'll get to it, a specific gravity test or something along those lines. But that battery charger should be getting those batteries back up to that 6.3 volts per battery. So here what we say is the best way to do it is to test a rested battery, because even if a battery does have some issues and you test it straight off of a charger, that surface charge can make it look like it's 6.3. So charge it, let it rest, even run the machine for just a couple minutes to get some of that surface charge off, shut it off, let it cool down, and then test it. One of the popular things, and it's amazing, we're the center of the service world, and we have about 400 techs out there that test it, and every once in a while we'll get some crazy battery testing information come in. The cold cranking amps on this battery was this. I don't know what in the world cold cranking amps have to do with deep cell batteries. I mean, I'm not trying to jumpstart the engine on these things. It's about runtime. Well, a handheld tester is a load tester is a pretty helpful and functional tool to diagnose a battery. But I will tell you, handheld or the load testers are not designed for deep cycle batteries to be a consistent resource that has absolutely failed or absolutely passed. One of the rules we do go by, though, is if you load test a deep cycle and it fails, then that battery is bad. If you load test it and it passes, you still have to do some initial investigation before you start saying that battery is good. A lot of bad batteries, and I've seen it here, especially with the AGMs where you can't do the hydrometer test to it, will pass the deep cycle or will pass the load tester, but then you only get 30-minute runtime on it because it has enough power to pass that short 10-second test, but it doesn't have enough of the chemistry left within it in order to provide the runtime that it should be hitting. And here what we're saying, the next part we have about component loading is one of the best ways, and we're going to talk, I'm going to skip this part, I'm going to come back to it after we cover the specific gravity. The gravity test is going to be a test that only can be on flooded wet cells because you have to be able to get access to the electrolytes. And remember, when the battery's fully charged, the electrolyte inside of it is sulfuric acid. When the battery's been discharged, that sulfuric acid turns to water. So basically, by doing a specific gravity test, you are registering the amount of minerals or slash, what that is, what is the components inside of the minerals, the elements of that. Pure water has a specific gravity of 1. Sulfuric acid has sulfur in there, is going to have that 2.65 or greater specific gravity. So it's really important. I've not seen specific gravities considerably higher, but if you go beyond the 1.65, if it gets well beyond that, could be some contamination or something along those lines. So again, don't add distilled water and do the test. If you just added distilled water, then you're going to have to use the system. You're going to have to use it and charge it, and you got to let that water dilute properly and to get the chemistry properly before you can do an accurate specific gravity test. But this is a very good way to be able to look at the health of each cell. Typically when a battery fails, it's not all 3 cells in a battery have gone bad. It's typically 1 cell within that battery. Doesn't matter though, the battery is still bad. Runtime. Now we're talking about depth of discharge here, and we're talking about where the batteries are typically cut off at. The more you utilize a battery, the deeper you discharge a battery, the shorter its life is. So if you're going to run a battery and do 100% depth of discharge, you're taking that battery down to somewhere in that 23 volts on a 24 volt system. It has here that is 1.75 per cell, so that's 5.25 volts. So think about that. Your depth of discharge on a 6 volt battery is 5.25. Theoretically in your head you're saying, well, that's not much use, but yeah, you've actually drawn that battery down to the point that it needs to be refilled to be charged again. Typically, you're looking at a battery, they're doing a depth of discharge about 80%. So you can see the theoretical depth of discharge of 80% on a 225 amp battery gives you about 3.6 hours of activity. Because, obviously, again, I told you about heat in battery cables, and there's internal resistance inside the batteries themselves. So your theoretical is 3.6, but your actual at prime is probably going to be 3.1 hours. So those are all factors. If you put brand new batteries in and you don't replace the battery cables, you're probably going to be at 2 point something, because you're already losing that extra voltage to heat. If you're ever looking at the battery specs, and batteries manufacturers have all, they all have different ways that they want to be able to show it, but one of the standards is a 20-hour rate. What's their 20-hour rate? And this is what the amp hours that you're going to use to be able to compare different manufacturers and different classes of batteries to each other. The 20-hour is the standard. So a 20-hour golf cart battery has about a 225 amp hour, somewhere in that range. Sometimes they'll show what the 5-hour rate is, what the 10-hour, what the 24-hour. So it's easiest to look at the 20 just to make sure you're comparing apples to apples. You can see on a golf cart that a 5-hour amps comes out to, with a 38 amp load, is about 190 amp hours. So it all kind of varies, because you're talking about, it says amp hours. Well, how many amps am I drawing out of it? So in order for it to be registered for 20 hours, that means that, that battery has to last for 20 hours. What's the average come out to be? And in this case, it's 11.25 amps over that time period. So, okay, runtime. One of our aces that we keep in our shop, we actually have about 6 of these or more, is a discharge tester. I love this thing. Lester makes it. what it does is it applies a static 75 amp load on those batteries. And you can buy the discharger there's 24 volt dischargers and 36 volt dischargers. And what we do is we set this up on the battery pack, we disengage it from the machine, we set this discharger up, and we just set it and let it go. And what it will do is put that 75 amp load on those batteries, on that battery pack, until it hits the cutoff, which on a 24 volt system is programmed to be 21 volts. On a 36 volt system is 31.5, and the discharger will automatically shut off at that point. You don't have to plug the discharger in because it's getting all of its power from the batteries themselves. And the nice thing about it too is it will shut off at 21 volts, for example, on a 24 volt system, but it still will have that residual power that it will be showing you. It will say, here's the volts when we shut off. Sometimes it's 21.2, sometimes it's 20.8. You know, it's just around that 21 point cutoff. And this is how long the test ran. From experience, and we've been doing a lot of these discharge tests, a healthy pack of new 6 volt 225 amp hour batteries will run for about 110 minutes. And I've seen it where it starts off at about 98 and 100 for new batteries and then goes through a few cycles and then increases in time, but it should be right about 110 minutes on that 75 amp load. That's really nice to be able to run that discharge test on this system versus trying to push that machine around for 2.5 hours to figure out how long those batteries are failing. It seems the magic number for people when they're complaining about runtime is an hour and a half. Man, it's a long time to run that machine for an hour and a half just to determine that the problem was the battery. So we use these dischargers all the time. If the battery's only hitting an hour and a half, that's about half of the time that it should be. So that test, will take just around an hour to be able to, less than an hour really, to be able to ferret out if the batteries are the issue or not. So, and you'll be able to see what the behaviors are. We use this test quite a bit with AGMs. I told you about the AGMs are a little bit different because it's all kept inside as far as the gases and whatnot. And what we see is sometimes those batteries, through either charging or something else, have been damaged, or a manufacturing process, because it has to be so much more precise, isn't up to snuff, is that the batteries show that they're very good, and you put a load on them over a period of time, and sometimes it's 15 minutes, sometimes you have to go 45 minutes, and all of a sudden it will drop from 24 volts to 20 volts in a matter of minutes. So it's kind of hit its point, and then boom, it just dies. And that's what the end user is finding, that I'm pushing the machine and at 90 minutes it just dies on me. And that's really, really frustrating, because you could load test it, you could volt test that and with the voltmeter, and everything appears right, but it really comes down to having a discharge test, or what was up here, we talked about component loading, about putting, actually doing the load test via using the machine's components. So a lot of times, especially on AGMs, what we'll do is we'll make sure the system's charged up all the way. We'll hook up a voltmeter with alligator clips and then run the machine and watch the voltage. And what we want to see is we want to see linear, predictable drops in that voltage. So it should be dropping. It should go 26.3, 26.2, 26.1, and so on. If you run it for 15-20 minutes and it's kind of just gradually going down, okay, then I'm not saying the batteries are fine at that point, but at least you've started to understand it a little bit more. A lot of times though, with bad batteries, you start putting a load on it, and those batteries will show 25 point something, but as soon as you put a load on it and you drive it around for 5 minutes, all of a sudden it drops to 23 volts. You have a bad set of batteries there, especially on some of the smaller machines, and that's very common with AGMs. So if you don't have one of these discharge testers, and I think Lester sells them for around $400, then that pushing it around is worth it. But I would highly recommend everybody have a 24 and 36 volt one in their system, in their shop if you're a tech. We've at USA Clean, we've been facing batteries and battery maintenance issues, helping our clients trying to save money for a long time. So we came out with a very simple device called the Bat Saver. That Bat Saver is not overly complex. It's not something that's going to be, it's going to take a laptop to run or something along those lines. The Bat Saver does two things for you. One is you hook it up right to your wet cell batteries. It has some copper shunts, and it just goes in line, very easy to install on the battery pack. And that Bat Saver will monitor the use of the machine and the recharges, and it will keep track of that inside of its flash memory. At 90 days or 100 hours of use, it will give you an audio alert that says, hey, it's time to maintain your batteries. It's time to stop, check the water level, clean the terminals, and then all you have to do is, it's an audio reminder. It beeps, beep, 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 beep. Okay, either I've gotten up to 100 hours of use on this machine, or it's hit 90 days. So I'm going to check the batteries. I'm going to fill the water level up to the proper one. I'm going to hit the reset. There's a little reset button there on the left. It's actually a little indentation. You can just use a paper clip, push that, and that will reset the Bat Saver. Before you do that, though, there is an 800 number on there, or a phone number that you call into. And I think there's 3 pieces of information that it will ask you. You just program it into the computer-generated system, IVR system. It'll say, hey, what's the first line of code? And you enter the digits, and then the next one, and whatnot. And we will, and that Bat Saver is tied to your specific machine. So if you have a fleet of machines, you can keep track and say who's doing their maintenance. If you just have one machine, you can say, well, this is how often we're using it. A lot of times people will say, well, yeah, our guys use it for 3 hours, but when you enter the data into the system, you'll see that over that 90-day period, they charged it 130 times, which means that they're opportunity charging. They're charging it too often. Second is they're only getting about an hour and a half of runtime out of it or something along those lines. So all that information is kept online. It's stored and can be accessed through your login at USA Fix. Very cool. If you want more information, be glad to be able to show you that or send you some specific things on the Bat Saver. If you don't maintain batteries, real-world examples, you're going to get less than 12 months. If you maintain batteries properly, you're making sure that the water levels are topped off, and you're doing that at the intervals that we have suggested, that you're going to be more in the 18 to 24 month range. But you can see that the chart on the left, the blue and the red line, both start off at 3 hours. And you can see over its first amount of usage, it actually goes up for the amount of time. That's what I described. And then following the blue line, where the batteries have naturally been taken care of, you could see that even well-maintained batteries, after 14 months, have already declined to about 2 hours of runtime. Well, 2 hours of runtime, if you need 3 hours to get the store scrubbed, obviously 2 hours is not long enough for what you need to accomplish. But it does show you kind of how that progression of a battery naturally falls over time. If you don't maintain the batteries, you can be down to 1 hour runtime in less than a year very easily. So a lot of guys say, I just replaced these batteries 8 months ago. How can they be failing? Well, have the electrolytes been replenished? Are you running it to full depletion and not doing a proper charge cycle? There's a lot of factors that come involved. Tips for improving the longevity, again, the water level is very important. If you allow 25% of that plate to be exposed, you've now lost 25% of your capacity of your batteries. You don't want to overfill. Sometimes, the people will fill it to the point that it's spilling all over. Don't allow corrosion to permeate. Make sure you're cleaning those posts off. We don't see as much overcharging anymore. Most of the modern chargers, most of them aren't running off of timers anymore. You're going to be utilizing a silicone chip or something along those lines, so it's sensing the voltage and it will automatically adjust based on the voltage. So you don't see as many issues with that. You got to make sure the battery charger is sized properly, which we'll get into. I will say that if you are storing a machine or not using batteries for a while, keep in mind that wet cell batteries discharge at a rate of 10 to 15% of their power every month. So you really don't want to go longer than 30 days or 3 weeks without charging that system completely. Because if it naturally declines to such a point, you are losing that capacity. It's going to start sulfifying inside of that battery and start ruining your plates. There's going to be a lot of issues. So we strongly encourage that if you're putting a machine off to the side, that you still plug in one of the modern battery chargers that will automatically trickle charge those batteries and keep them healthy. And here we talk about batteries left in discharge rate will sulfate and lose capacity. Signs that you have a problem with batteries is swollen. If you have swollen batteries, immediately stop using it. That means that they're overheating or they're not venting properly, something's happening, and that battery pack is going to have to be replaced. Especially if that battery pack is over 6 months and you only see one battery that's being swollen, you still will have to replace that battery pack. Don't allow them to dry out, and that picture of a corroded terminal is real life of what we see. I think we just had to go out to one site to be able to find battery terminals that kind of look like that to get that photo. So that's the sulfur forming around the terminal that's escaping, and then the electrical reaction is causing it to corrode there. Eats right through the battery terminal, eats right through the battery cables, starts eating up the battery. Okay, we're going to jump right to the chargers here. Thank you for your patience and being part of the presentation. Hopefully we're covering the questions that you have on batteries. I won't take a lot of time with chargers. One of the things I do want to reinforce is that AGM and wet cell and gel configurations for chargers are very important. Wet cells, pretty much a wet cell battery can be charged by any wet cell configured charger across the board. Just make sure you match up a 24 volt charger with a 24 volt system, or a 36 volt with 36 volt system. That's very important. Allow it enough time to do a proper charge. Chargers, through the natural cycle, actually go through 5, 6, 7, depends on the charging company, but they go through a series of stages. Some stages in the charging cycle will have a higher output of amperage, and then sometimes it trickles down. One of the important things to consider is that AGM batteries and gels cannot vent the gases. So what happens with an AGM charger is that it will reach about 2.3 volts per cell, and that charger will significantly decline the amount of amperage that it's putting inside that battery. Why it's doing that is that it doesn't want that electrolyte solution or inside of it to start gassing. In a wet cell, they still continue to push higher amounts of amps at that point because the gas can escape from it. But with a wet cell, that's when you get damage inside of it, and you also get bulging and other issues that can go on. So it's very important to make sure you got the right configuration. The other one is, can I use an AGM charger on gels or vice versa? The answer with that is pretty much uniformly no. Some charger companies say yes. You know, that's your own discretion, but I can tell you that the battery manufacturers themselves say no. You need to stick with an AGM setting or a gel setting, because they're, again, the cutoff points and how they charge the batteries is different. I think Lester once told us that they have 76 different algorithms that kind of determine on how an AGM battery should be charged. Seems pretty complex. a good rule and thumb that for techs and for end users and managers and everything like that is to get a battery charger that is about 10% of the amp hours of the battery. And in this example, he's got to put a 10 amp charger with a 100 amp hour battery. In the real world, if you're using a 225 amp battery, amp hour battery, golf cart batteries, then that means that you should be somewhere between 20 and 25 amp charger is what you should be utilizing. If you jump up to the 305, the 300 volt batteries, amp hour batteries, excuse me, 24 volt or 36 volt, 305 amp hour, then you're going to want a battery charger somewhere between 25 amp hours and 30 amp hour, or excuse me, between a 25 amp battery charger and a 30 amp charger, somewhere in that range. If you try to size one that's undersized, one is it'll take a lot longer for it to go through its charge cycle. Two is it will typically never finish the charging cycle, will never get the batteries to the final stage that they need to be to keep them healthy. If your charger is too high, then it's going to be pumping in too much amperage into it, and you're going to end up baking the batteries. So just make sure you're sizing it. All the service manuals for all the machines will indicate what size charger should come with it. Again, 25 amp hour charger is pretty much the sweet spot. That's pretty much concludes today's webinar on wet cell batteries. If you have any specific questions, feel free to jump in. You can either just ask them online so everybody can hear you, or you can type out the questions or a chat. I'll stick around for a couple minutes if you just want to do that after the fact. But I do appreciate you being part of our webinars. We do have this webinar series every 3 months. I think we have about 5 different topics that we cover, everything from proper how to PM a machine to battery technology and whatnot. And we may in the future focus a little bit more on chargers or some more advanced subjects. I know we have something on propanes coming up as well. So